In today's handout, we'll talk about properties of logarithm and how you use that to solve some of the equations and expressions. Let's start with section 1, properties of logarithm. So we have 7 properties right here. We will use example 1 to demonstrate these properties. Number 1, log base 5 of 1. So this one will use the first property right here. If you have a log where the value inside the log function is 1, then the result is 0. This comes from the fact that a to the 0th power is 1. So notice that they have the same base, right? Base A. And then from previous handout, you should know that we simply switch the two numbers right here to rewrite the log equation to an exponential equation. This is the exponential form of this log equation right here. And from the exponential property, we know that if you raise a number that's not 0 to the 0th power, you will get 1. So that's how you get the first property. And according to this property, we know that log base 5 of 1 has to be 0. And then since we're here, let's finish practice 1 as well. Number 1 is log base 13 of 1. So it's the same thing, right? The base is 13. 13 raised to the 0th power is 1. So the result is still 1. And that's the first property. And these properties, they do have some restrictions, by the way, in terms of the base. The base A has to be positive, and the base A cannot be 1. So those are some restrictions in terms of the base. Now let's look at number 2 of example 1. This one is log base 7 of 7. Log base 7 of 7 is 1 according to the second property. So why is that? It's because if you look at the second property right here, it says log base A of A is 1, but why is that true? This is because when you raise base A to the first power, you get A. That's why. And of course, I'm not going to prove all of these properties, but some of the simple properties like these two, we're able to demonstrate right away. Let's finish practice 1 as well. So this is log base 9 of 9. According to the second property, it's also 1. Number 3, 5 to the log base 5 of 15. So this one, we have exponents and we have logarithm in one expression. And from the previous handout, we should know that exponential and logarithmic, they are inverse operations if they have the same base. So in this case, we have, as you can see, exponents of 5, and we also have log base 5. So they have the same base. As a result, they are inverse operations. So what you do is you simply cross them out, and then you write down what's left. So if you cross them out, we have 15. You could also use property number 3 to demonstrate that, but simply the reason why they cancel out is because exponents of A and log base A, they are inverse operations. Let's finish the practice side as well. So this is 2 log base 2 of 8. And again, the base 2, exponents of 2, and the log base 2, they are inverse operations. So you could just cross them out, and we have 8. Okay, number 4, log base 7 of 7 to the 4th. This one will require you to use property number 4. So let's take a look at property number 4. Property number 4 is kind of similar to number 3. So instead of having the exponents first, we have the log first. And then there is an exponent of the same base inside of that log base. As what we deducted before, log base A and exponents of A, they're inverse operations. So we simply cross them out. In this number 4 right here, we have log base 7 and we have exponents of 7. They're inverse operations. You cross them out. They cancel out. We have 4 left. On the practice side, log base 2 of 2 to the 15th, log base 2 and exponents of 2, they're inverse operations, so you cancel them out, and we have 15. Okay, number 5. Log base 3 of 3x. So this one will require you to use property number 5. Property number 5 is a product rule. So let's see. We have a log base A, and then we have a product inside of this log function. So notice that there is a pair of parentheses right here. That indicates that m times n is inside of that log function. And according to this product rule, you simply expand this log function to the sum of two log functions, each of them taking one of the factor in the original product. So this is log base a of m plus log base a of m. It's a way to expand the log expression, but it's also a way to condense a log expression if you have multiple logs. But this one, for number 5 in example 1, we have just one log, but we can use this property to expand it and evaluate. So according to this property, you will do log base 3 of the first factor, which is 3, and then plus log base 3 of the second factor, which is x. And the first factor inside the log base 3, we're able to evaluate this, right? Think about which property. It's property number 2. So check it out. It's a log base a of a, right? These two are basically inverse operations. They cancel out, so the result is just 1. Or you could use property number 2 to figure out, and this is just 1. And then the second one, since we don't know the value of x, you just copy it. Log base 3 of x. I'd like you to finish the practice side number 5. Restart the video when you complete to check if your answer is correct. Okay, assuming you finished, according to property number 5, we're going to split this factor. So you have log base 9 of 9 plus log base 9 of x. And then the first part, log base 9 of 9, is 1 according to property number 2. Plus log base 9 of x, and that will be the final answer. Okay, number 6, log base 2 of axy. So for this one, we're going to continue using property number 5. This is because we have a product inside of this log function. We're able to split it. Let's split it. We have log base 2 of 8 plus log base 2 of x plus log base 2 of y. And then for log base 2 of 8, we're going to apply a property. First, I'm going to rewrite this 8 as same thing, base 2. So it's going to be 2 to the third. And you might wonder, why do I rewrite 8 as 2 to the third? This is because the log function has a base of 2. And one of the property, if you remember, is property number 3. Actually, no, property number 4 suggests that if you have a log base a and the exponent of a together, they can cancel out. So that's exactly what I'm doing right here. We have log base 2 outside. I want to turn the inside into an exponent of 2 as well. And 8 happens to be 2 cubed. So that's why I did the transformation right there. And the other two, since we don't know the values of x and y, we just copy them. Okay, and then for the first part, we know log base 2 and exponents of 2, they're inverse operations, so they cancel out. The final result is just 3 plus log base 2 of x plus log base 2 of y. All right, I'd like you to complete the practice side. Start the video when you finish. Okay, so this one, I'm going to do something very similar. It's a product inside. I'm going to split it. So the first one is log base 3 of 27, and then plus log base 3 of x plus log base 3 of y, right? And then this time, I'm going to rewrite this somewhere else so I could save some writing. For this one, hopefully you did the transformation. So starting with the base in the log function, it's 3. That means you need to rewrite 27 as a base of 3 using exponents. And if you use your calculator or if you just use some mental math, you will know that 3 to the third power is 27. So this is how you rewrite log base 3 of 27. And then you're going to cross out the inverse operations, right? So the inverse operations are log base 3 and exponents of 3. As a result, we have 3 left. So the first part is just 3. Since we don't know the values of x and y, you copy the other 2 logs. Okay, number 7, log base 5 of 5 divided by 7. This one we will use a new property, which is property number 6. Property number 5 deals with a product, and property number 6 deals with a quotient. You can see that there's a quotient inside of this log function, and according to property number 6, we're going to split them and subtract. And this probably reminds you of the exponential property, right? So in the exponential property, we also have something that if you multiply, you add, if you divide, you subtract. So that's how you can make connections between the exponents and the logarithm. They're very similar. So let's apply this property. So this is log base 5 of 5 over 7. We apply that property, we will split them and subtract. So log base 5 of 5, subtract log base 5 of 7. And then for log base 5 of 5, apply property number 2. It's going to be 1. Or you could simply use inverse operations, right? So log base 5 and 5 cross out. Whenever you cross out, it becomes 1. So in this case, we get 1 minus. For the second one, we don't know the answer now, but later on, we will have a way to calculate this. For now, let's just keep it like log base 5 of 7. All right, let's complete the practice side. Restart the video when you finish. Okay, so this one, you're going to split as well. So we have log base 4 of 3, subtract log base 4 of 4. Log base 4 of 3, we don't know what it is, so let's just keep it as it is. And log base 4 of 4, we know it's 1. This is because of property number 2, or you could cross out the inverse operations. And then here I want to point out something about the values inside or outside the logarithmic. Notice this expression right here. Do not combine these two, okay? The 3 and the minus 1, do not combine them. This is because the 3 is inside of this log function. So that's one term by itself. And then you have a negative 1 that's outside of the log function. That means you cannot combine them, okay? So that would just be the final answer, and that's it. Okay, number 8. Number 8 is log of x divided by 100. So notice that this one doesn't have a base. And according to the previous handout, it's one of the common logs. If you don't see a base in a log function, the base is 10, right? So there is a base 10 right there. But we will still use the same property, which is the quotient rule. We're going to split them. So you have log of x and then subtract log of 100. And then I'm going to put the base back right here, log base 10. For the first one, I'm not going to put it because we don't know the value of x, so we can simplify that anyways. But for the second one, we are able to simplify it. So let's highlight this part and then let's do some simplification. Since the base is 10, I'm going to rewrite 100 as an exponent of 10. And it shouldn't be too difficult to figure out that 100 is 10 squared. So that's how you rewrite 100 as exponents of 10. And then we apply the property, right? The inverse operations, log base 10 and exponents of 10. So you could cross them out. We have 2 left. And as a result, this evaluates to log x minus 2. Okay, let's finish the practice side. Restart the video when you complete. Okay, so this one is very similar. We have log of x, subtract log of 1000. And because there's no base, the base is 10. And then for this 1000, you could rewrite that. This becomes log base 10 of 10 cubed. And you can cross out the inverse operation, log base 10 and exponents of 10, which is 3. So the final answer is log of x subtract 3. Okay, number 9. Number 9 is log base 7 of 5 to the 4th. This one, we will use the last property on the first page. The last property on the first page talks about an exponent inside the log, but the exponent's base is different from the log base. So before, we have property number 4 right here, right? So these two, because they have the same base, so log base a and exponents of a cancel out. But what happens if you don't have the same base, but you still have an exponent inside? So this p right here is the exponent. You cannot just cross these two out and say the result is p because they don't have the same base. But you can do something, which is taking out this p and put it in front of the log, or you could say outside the log as a coefficient. So that's what the property says. You basically take this exponent p outside, put it in front of the log, and that's the right hand side. So let's come back to this number 9 right here. We do have a log base of 7, and inside of the log we have exponents of 5. They don't have the same base, so we cannot cross them out. We can, however, bring this 4 to the front of the log. And you're going to rewrite it as 4 times log base 7 of 5. And that's it. Let's use the practice side to practice this property. Okay, so this one is also very similar. They don't have the same base, right? One is 2, the other one is 3. So what you do is you take out the 7 and put it in front. 7 times log base 2 of 3. All right, we're done with the first page. So make sure that you know these 7 properties and how you apply them, because this will become the foundation of the second page. Let's move on to the second page. Example 2 says you're going to expand this log expression. This log expression has a product inside, so we're going to apply the product rule, which is property number 5 right here. So according to this, you split each of the factor and then write it as a sum. Let's do that. So I'm going to do equals, right, log base 2 of 5, that's the first factor, plus log base 2 of x to the 4th, plus log base 2 of y squared. So this is the splitting according to that property. And then is there something else we can do? Yes, there is. So according to property number 7, which we just did, if you have an exponent inside, but the exponent doesn't have the same base, you can bring out the exponent, put it in front of the log. And we do have exponents right here, exponents right here that are inside the log, which means you could bring out the exponents. Let's do that. First one, log base 2 of 5, we don't change it, so we just keep it. Second one, we're going to bring out this 4 and then put it in front of the log. That would be 4 log base 2 of x. And then plus, next one, we have this 2 that we can take out and then put it in front of the log. So this will be 2 times log base 2 of y. And that's it. That will be what it means by expanding this log expression. You're making it more complicated. And then for example 3, this one is a little bit too complicated, so I'm going to skip this one. But if you are curious, I can give you the final answer. It is definitely a challenge, but I think it's not really required for you guys. However, if you do want to know the final solution, this is the final expanded form. Yeah, as you can see, this is definitely way more complicated than the original, right? So that's why in real practice, it's probably better to do the opposite of what we just did, which is example 4. We can sometimes condense an expression that has multiple logs. We could put them together, which is probably better, right? So let's do one example right here. Example 4, we're going to condense these 3 logs, put them together. And this will require you to look at the base and look at the operations in between. So what do we have? We have log base 2, log base 2, log base 2. Perfect. They have the same base. So let's go to the first page. You're going to use these two properties. Notice that if you have a summation, which is a plus in the middle, right here, then you're going to write them as a product inside a single log function, right? If you have a subtraction in between, then you're going to write them as a quotient inside of the same log. And now we have both of them, so we're going to combine property 5 and property 6. Let's use this one to demonstrate. So first, we're going to write the main log function, which is the common log function, log base 2. And then inside of this function, we're going to look at the operations in the original expression. So we have plus right here, which means we have to multiply 5 and x. So I'm going to do 5 times x. And then we have this subtraction. Subtraction means we have to divide. So we're going to divide 5x by y. And that's it. So that's how you condense example 4. All right, I'd like you to complete practice 2 on your own. And when you finish, you could restart the video. Okay, so this one condense. We do notice that they have the same base. This one might be a little bit harder for you because we also have these numbers outside, right? These numbers outside is a little bit annoying. So how are you going to combine them? You have to put them inside of the log before you apply property 5 and 6. This is because if you look at property 5 and 6, the coefficient of the log, they're all 1, as you can see, right? The coefficients are all 1. So if you have a coefficient that's not 1, you cannot apply these properties. So how are you going to make the coefficient of the log 1? Well, there is a property number 7, that helps you. So pay attention to the right-hand side. The right-hand side, we have a coefficient, which is p. This can be any number that's not 1. And applying property number 7, you could bring this inside as an exponent. As a result, your coefficient of the log becomes 1, which allows you to apply properties 5 and 6. So that will be the main idea that we're going to do right here. Let's start with the first one. The first one, we have this 3 outside, so we're going to put it inside on the top right of x. So this will becomes log base 2 of x to the third. So you want to make sure that the coefficient of log is 1, plus the second one is same thing. We have this coefficient of 2. We want to make it 1. So we're going to use property number 7, bring it inside, put it on the top right. So this will be log base 2 of x minus 1 squared. Make sure that you put it outside the parentheses. And now we have a summation of the same log function. That's base 2, base 2. And that means we can apply property number 5, write them as a product. So it will be log base 2 of, and then you just multiply those two. It will be x cubed times x minus 1 squared. And if you want to make sure that they're inside of the log, it's optional, but you can also put a pair of brackets around them. So we know that this whole product is inside of that log base 2. And that's practice 2. All right, the last section is change your base formula. So if you pay attention to your calculator, you might notice that your calculator can only compute 2 kinds of log, right? One is the common log, which is log log base 10, and the other one is the natural log, the ln, or the log base e, right? So you can only calculate these 2. Most of the scientific calculators are like that. Some calculators are able to calculate logs of any base. But for most people, you don't have that calculator because it does take a lot of power to compute that. So not all calculators can do that. As a result, we have change your base formula, which will allow you to compute log of any base. And there are 3 ways that you could change your base. Let's just check out the first one. The first one here, it says if you have a log base a of n, and where a is not a common log or a natural log, how do you calculate this on your calculator? You could change this base a to any other base that you can compute or calculate on your calculator, like base 10 or base e, and then you write down the m, the original number inside, as the top, and then the a, the original base, as the bottom. So that's the change of base formula. The other two formulas right here, this one just changed the base to 10. That's why there's a common log. So it's just 10 and 10 right here. Or you could change them to natural log. So ln m over ln a. So these two are just specific examples of changing that base to either 10 or e. And I would recommend you do either 10 or e, because those two your calculator will able to handle. For example, let's approximate example 5, log base 3 of 42. Log base 3 of 42. And we're going to use the change of base formula. I'm going to change it to just the common log. So that means I'm going to have a quotient. So you could do a fraction bar first. And then you could write down the log that you decided to choose, right? I'm choosing common log. So it's just going to be log. On your calculator, it's just log. And then you put 42 on the top, which is the number on the top in the original as well, right? So you could kind of just see this is on the top, this is on the bottom. So that's why 42 goes to the top, 3 goes to the bottom. So log of 3. And then go to your calculator, calculate these two and divide. So for this one, you're going to get this is approximately 3.402. And if you are curious, you can also change them to natural log. I would say give it a try, right? So if you change it to natural log, it will still be a quotient, but it's going to be ln. So you have ln of 42 divided by ln of 3. And if you don't believe me, go to your calculator and calculate these two and divide. You're going to get the same number, 3.402. All right, let's complete the practice side. You're going to approximate log base 5 of 46. Same thing, you can just keep 3 decimal places. Okay, so for this one, I'm going to change it to common log. So in this case, it will be log of 46 divided by log of 5. And if you use your calculator, it's going to be approximately 2.379. And of course, if you change it to natural log, it's going to be ln of 46 over ln of 5. And that will also give you approximately 2.379. And that's this handout. Thanks for watching.